Hello, everyone. This is Veysel, CTO of Johnson Labs. So today's topic is matching patients with clinical guidelines to show you how we can match the patients that we are treating in a clinical settings and how to match these patients with the clinical guidelines that are readily available. So we have a large agenda today. This, as you know, this is going to be a 45-minute session. So I'm going to try to cover as much as possible, and I will also spare some time for a demo. So we will have two different demo sessions at the beginning and at the end. So we will start with the role of the clinical practice guidelines in healthcare. So from now on, I'm going to call it CPG to make it to shorten it a bit. So the role of CPGs in healthcare, why we are using it, how complex they are, and how they are generated, and how useful they are. This is the first topic that we are going to go over, because we need to understand why we need such an automated solution to match the patients with the CPGs. The second topic will be how to leverage these CPGs, these guidelines, via Gen AI or AI or any automated tools. So are there any opportunity or blockers? How to utilize the latest state-of-the-art techniques to leverage CPGs efficiently in a clinical setting, so that we can make the life of healthcare practitioners as easy and efficient as possible. Then I'm going to have a short demo, because so far we have had covered the role of CPGs and are there any opportunities. Then I'm going to show you how that end product works actually, because I'm going to ask some questions to a demo app that we prepared. We have some demo app that I'm going to show. So it's going to be a live app. Then I'm going to ask some question and get some answers, and I'm going to show the answers from the corresponding pages. This is going to be the setting the stage for everyone, so that the next steps, like how we do all of such a solution, would be more vivid, more clear in your mind. Then we will start. I will go back to my presentation and I will try to explain the modern approaches to query CPGs efficiently, because this is not the only solution out there. There are some other approaches that I think people are using according to what I read, what I saw, or what I feel, or what is possible out there. So everything that is written here, these are all my ideas and my like as a company, of course, there are some lessons learned and best practices developed for the last 6 years that I got a chance to lead a great healthcare NLP team at Johnson Labs. So I'm going to go over the modern approaches, not just at Johnson Labs, but by the other practitioners, or what else could be done to query CPGs efficiently. I'm going to go over those steps. Then I'm going to touch upon briefly how to build patient journeys in clinical settings. Why this is important? Because the title is Matching Patient with Clinical Practice Guidelines, right? So not just the patients and patients' admission diagnosis or admission complaints, right? So we need to build the unified view of the entire patient with the existing resources and EHR records, etc., then match to the CPGs. So that's why we need to create that unified view. That's why we have another product at Johnson Labs, which is called Patient Journey. So I'm going to show you how we build the patient journeys in clinical settings. I'm going to briefly touch upon that because it's the part of this flow. Then I'm going to go over the most important part of this webinar, which is a flow to match patients with CPGs. Like I'm going to cover each steps of such a flow and why we need that steps to accomplish certain tasks in that flow to accomplish matching the patients with CPGs. Then the last but not least, so evaluation of multimodal LLMs and tools. So I'm going to evaluate certain tools. What could have happened if I had used other tools rather than our own solutions? Or what are the pitfalls if I just pick some other LLMs or some OCR tools to extract information and write into a vector DB? What could be the outcome if I had just done it blindly without paying too much attention to the context of the CPGs? And then I'm going to end the webinar with another demo So I'll cover 4 to 5 different questions in that demo, and then I'm going to show where those answers comes from, because in the demo you will see 3 different approaches that we develop. So the first one will be vanilla approach. It will be just a simple approach that everyone else is doing. And then we have intermediate solution, and then the final solution that I'm going to show you the differences between each one of them on live questions and answers. So let's start with what CPGs are, clinical practice guidelines are. So clinical practice guideline, as you might see, is one of the most important pillar of an entire clinical decision support system in a clinical settings. So CPGs are systematically developed statements, documents, brochures, catalogs that are designed to optimize patient care by providing evidence-based recommendations. So they are the compilation of multiple resources, articles, clinical trials, some best practices that are developed and gathered by multiple experts through the years of experience, and then they are created from systematic reviews and assessments of benefits and harms of care options, what other healthcare professionals or practitioners did, what kind of decision they made and they ended up with. So it's like a handbook for any physician, especially when they are at the early stages of their career. They are relying more on these kind of resources than their own experience and mind, right? Because through years, after 5 years or 10 years, physicians, healthcare practitioners are developing some sense that they are not relying that much on the CPGs or hard coded manuals, right? They are using more intuition, and they are developing some intuition and common sense, and they rely more on their own observations on experiences. But as a physician, there is no way you can see all these cases before, even if you are 30 years. Even if you have more than 30 years of experience. That's why CPGs are still useful in a clinical settings, because there are some principles while developing CPGs. They need to be evidence-based, they need to be multidisciplinary, they need to be standardized, they need to promote evidence-based practices, and they support clinical decision support systems. So CPGs are mostly paid resources. Actually, I'm going to touch upon that as well. But as of 2011, the resources are not that rich, by the way, because I could only find the statistics back to 2011, and there are more than 2,700 clinical CPGs. But as far as 2003, 2022, I think there are more than 3,700 CPGs out there, according to what I found. So how did I find this? There's a website for this, Guideline Central. I'm sure there are many others. This is one of the paid ones. As I said before, CPGs are usually behind paywalls. You need to be a member of certain association so that you would be able to use these resources. Handful of them are still open source, which you can find in PubMed or some journals, open source journals. But most of them are paid and not easily accessible if you are not a member of certain association or institution. And they catalog 3,700 CPGs as of today, as far as I see. And on the left-hand side, you see the top 10 most viewed clinical practice guidelines in 2022. So at the first glance, most of the time cardiology-related and diabetic-related clinical practice guidelines are highly popular in clinical settings. As you see, the first one was related to heart failure, which is developed by American College of Cardiology and American Heart Association. And more than 166,000 times they are downloaded and viewed. And we have some atrial fibrillation, schizophrenia, acute ischemic stroke, and some diabetes and thyroid-related CPGs out there as well. Which means that people are using this on a daily basis, but they are hard coded. There are some documents, right? Even if you print it out, they are document, or even if it's an online document like PDFs, you still need to turn the pages and then find the relevant information. which might be a very non-trivial process in the clinical settings. So how do they look like? Here's one of the examples that I found. I'm going to show you 3 examples, by the way. The first one is diabetes management in chronic kidney disease. This is developed by American Diabetes Association and showing some guidelines how to manage diabetes if the patient has a chronic kidney disease. So most of the time, CPGs are full of visuals, charts, diagrams, flow charts, and to make it easy to find. Because in a clinical setting, you usually, like the practitioners, usually don't have time to read pages of information. So that's why they usually need to turn the pages and then find the right diagram so that they can just follow some steps, some if-then-else cases, and then try to find out if the patient that they are trying to treat or observing could be a nice example, could benefit from these facts, right? For example, in this table on the right-hand side, you see that which kind of glucose lowering agents you should pick given the type 2 diabetes or chronic kidney disease, or what kind of medication you need to use under which condition, or how to screen certain patients, or when to screen that patients, right? So these are all guidelines developed by other bigger minds and based on a clinical observation and facts. So that's why it makes practitioners' life a lot easier when they are in doubt, especially. This is another one which is developed by American Heart Association. It is explaining how to diagnose and manage aortic disease. As I said, CPGs are full of flowcharts because it's how the human mind works, right? Easily, if you have certain profile in your mind, you just wanna just scroll through or go through some charts and then find your own situation because there are a million other combinations over there. So, but CPGs are the condensed version of this combinations that is very that makes practitioners' life easier when it comes to solve certain situations or make a decision in certain hard situations. For example, how to treat patients who have Marfan syndrome, or when to apply genetic testing if you are treating a thoracic aortic disease patients. And if the patient's genetic testing is negative, what happens next, what you should do next, or if the patient is older than 60 years old, what you should do. You should do genetic testing, or maybe skip the test and do something else, right? This kind of flowcharts are the outcome of years of experience by the other physicians or other research. So it's CPGs, one of the most important aspects of CPGs is to convert or translate academic research into a clinical practice so that you can just readily use readily available solutions out there at your fingertips. This is the last CPGs that I would like to cover. So this is a guideline for screening and management of high blood pressure in children. So it's again full of tables. So if the kid is less than 10 years old, but the blood pressure is less than 100, systolic pressure is less than 90, and what you should do. There's a nice, easy to understand flowcharts over there that is guiding the practitioners what to do when. Because, as I said, in your lifetime as a physician, you only had a chance to see a certain number of cases, and then CPGs are there to condense the entire knowledge gathered by the other practitioners throughout the years that you can apply on your own case easily. But as I said, you need to turn the pages and then find this information. So, but what if we have an automated solution to do this, right? What if you index all these CPGs into some automated system and then you ask a question with the case at your hand and then see what are the treatment options or what you should do, rather than you turn the pages and then find that certain flow chart, and then follow the diagram, and then find your answer, because you don't have time to do this in a clinical setting, right? Because patient comes in, you need to find his own history, you need to check the HR records, then you need to find the right CPG that would be applicable to this use case. Then in that CPG, if you are lucky, if you find the right CPG, you need to find the right page, right chapter, and then find your answer, right? Let's do some live demo here. So I have an app which is running here. So for example, if I ask a question about, right, like, so let's say that what is the immediate treatment option for type A aortic dissection with rupture, tamponade, or stroke? So we need to find the right CPG. Yeah, imagine that I have a type A aortic dissection patient requires such a procedure. So what are the immediate treatment options for such patients? So I can just run it, and then with this tool, with the help of this tool, it's going to show me the right page and right document given this patient's situation, right? So because we have different approaches that I'm going to also explain during this webinar. So the multimodal approach that we develop is going and then finding the right flow chart here, because my question was, as you remember, my question was immediate treatment options for type A aortic dissection, right? So if I just go to that chart, right, so I can just go through like this chart and then turn left, and then rupture and stroke. So I found, so it should be immediate ascending aortic arch surgery. So that should be the answer, right? Let's see what my tool returned. You see here's the response. It says that the treatment option is ascending aortic arc surgery, right? So it's pulling this information from this chart. If I had used other approaches, classic approaches, and then run it again, it's probably going to fail, right? Because it says that urgent surgical intervention. I'm not a physician, so this information might be correct in some situation, but according to the flowchart that I see right now, this information is wrong. Why? Because even if it found the right pages, right, since the vanilla approach cannot understand the flowcharts in a way that multimodal approaches can understand, it's probably picking this information from the text, right? And then, as I said, you may not have a time to read all the text. Of course, it has so much information over there. But the vanilla approaches are usually leveraging, which we call retrieval augmented generation, right? This can also be regarded as a one form of RAG. So over there, if it's text heavy, you are lucky, because any vanilla approach could probably work over there if you do some post-processing and pre-processing precisely. But if the answer lies in the chart, there's no way you can find an answer with a vanilla approach. For example, I can ask another question. What criteria for genetic testing if you are treating a thoracic aortic disease patient? So it returns this. This is Bayes approach, and the answer is they have family history of tape. They have an early age of disease onset, right? So looks like it's working fine. Let's do multimodal and then run this again. As I said, if it's text heavy, usually you may not even need multimodal. So right now, the multimodal one, you see it is more richer because it is using the guidelines precisely, and it even found the right chart for me, right? So it found the right chart and then explained the results clearly, because this is what the model sees, and then generating these answers, just like you find the right page with your own hand and eyes, and then generate one synthesized answers. Okay, we are going to have another chance to have a demo, but let's get into let's get back to presentation and then explain the next steps. So, as I said, there are multiple way of querying these CPGs. So the vanilla approach would be search engine, right? Just like you Google it, you might have a search engine which is based on keyword search, and then you might be doing exact match, fuzzy match, approximate search. But information spread over multiple pages, no semantic search, hard to synthesize answers from multiple resources, because even if you do Googling, right, that it returns 10 answers, but it's you need to synthesize the answers and then find the right link, right? That's why there are some other startups doing this synthesize answers rather than list of links. So the first approach is usually, and 90% of the time, they are still behind search engine, all these CPGs and all these guidelines, knowledge bases. But with the help of Gen AI and LLMs, there are new techniques that people are testing right now and experimenting right now. The first one is fit into an what if LLMs are that smart, large language models are that smart, why not I just feed the entire CPG into an LLM and then query? It's like you give a one page of email and then ask a question, right? Or one page of clinical note and then ask, okay, what are the main diagnoses for this patient, etc. So why not we just do the same, right? But LLM's context windows are short. It's very expensive process, and even if the most capable LLM out there, their capability of generalization deteriorates after 32K context window. So after 32,000 tokens, it starts to do really worse because of the certain phenomenon like lost in the middle, because the LLMs tend to pay more attention to the information at the beginning and at the end of the context. So it kind of lost in the middle. So you need to ingest CPG again and again. At each question, you need to send this context. Like imagine you have 100 page of TXT file. You wouldn't want to send this to LLM again and again because there's a time to first token versus token per second. So it's going to be very slow and expensive. The second one is, what if you fine tune an LLM over question answer pairs from CPGs, which means that LLM has its own knowledge. What if I train, right, LLM to learn entire context? The cheapest way would be fine tuning with some techniques like LoRa, etc. Right? You can, but LoRa needs some pairs, right? So you need to give some input and expected output. So you can just generate QA pairs from CPG. So you kind of represent the entire context of a CPG to use as a SFT, supervised training data set, and then fine tune an LLM. So it's easy to fine tune, but there's a high risk of hallucination because you may never know if the existing knowledge is larger than the new knowledge that you inject, and if you did the training well, and if LLM is hallucinating because no reasoning across pages, because maybe the information is spread over 5 different pages in the entire CPG document. LLM cannot jump from one page to another. Another one is continual pre-training. So the idea is that what if you just show all the CPGs PDFs to LLM so that it keeps training. It doesn't rather than only fine tune certain parameters. It keeps training and then fine tune entire checkpoints, entire backbone. It is non-trivial and very expensive process. Again, risk of hallucination, very slow. It may lose generalization capability and so on. So another approach would be convert CPGs into structured format. Some people use business process mining techniques. Some people use knowledge graph. So you can extract all this information just like any source document and then create a structured data so that you can query with a structured query language. This is expensive and laborious process. Query is faster, very deterministic, but requires expertise. And then while you are converting CPGs into structured data, there might be some hallucination as well. Or build a RAG framework that most of the people will probably pick out of these options. But over there, as I said, there are different techniques that you need to pay more attention to the context of CPG. And you shouldn't just blindly write into split the documents into chunks and then write into vector DB, but you need to pay attention to multimodal nature of CPGs, which I'm going to cover. So How to find appropriate clinical practice guideline, because you have a case in your hand, a boy with 12 years old, a boy less than, like younger than 12 years old with BP less than 112, etc. So you have a case at your hand. You augment that case with the existing information that you extract from EHR. Now you need to find your way around this 3,700 CPGs. So there needs to be a better way of doing this, right? And while augmenting the data that you have, because you cannot just rely on the admission criteria or admission facts, like the facts that you have in the admission, right? You have a patient younger than 12 years old. You have the BP results. He is vomiting and he has infrequent seizures. But you need to now augment this information with EHR data, with the patient history, using file records, using EHR records, some tabular data, some unstructured note. So you have years of records maybe for the same patient. So you need to be able to synthesize all this information and build a unified patient journey. That's why Johnson Outdoors has been working on a patient journey solution that is doing this on the fly. Whenever you have a patient, you will have this journey on your at your fingertips right away. So that's why if you augment the patient admission complaints with this data as easy and as efficient as possible, now you have the patient profile that you can go and find the right CPG. Because the patient data comes from multiple resources and each one of them might get lost down the road. We have a webinar done by CEO of Johnson Labs a month ago. I suggest you go ahead and then watch this. You can find it on our website. It's explained the unified patient journeys, how to go from EHR to and unstructured text to unified journey by using OMAP schema. So it's a large product that we are still working on. So basically, we augment the existing situation and then map it with the clinical practice guidelines. So now the job is how to find the right CPG. Even if you find the right set of CPGs that would be applicable to your use case if you need them, how to get the answer that you need. So you have the case, you use Johnson Labs Unified Patient Journey product to augment it. Now you have the right-hand side, right? You only have one sentence at the beginning. Now at the end of the unified journey, you have all this information extracted from the patient's history and EHR records. Now the next step is, given this unified patient profile, finding how to find the appropriate clinical practice guideline. So we build a agentic flow over there to pick the right set of CPGs rather than blindly search my whatever I need among thousands of CPGs, right? It would be so it would be over optimistic, naive to think that we can find the right set of CPGs right away, because we are talking about 100 plus pages of CPGs out of 3,700 cases, different PDF files. So that's why agentic flow, this is the first step in the GenAI flow, that you can find the most appropriate set of CPGs with the help of this flow. Then you end up with, let's say, 6 different CPGs that would be more applicable for use case. Now imagine there is a magic wand that you found the 6 CPGs right away on your screen as a physician, but it is still non-trivial process to find the right information out of 6 different CPGs. You will just search, you will just turn the pages. Luckily, we have a flow for this, right? We have a multimodal CPG RAG flow. We call it multimodal CPG retrieval augmented generation flow, which is now downgraded the entire problem into 6 different CPG. Now the rest of the flow will be handled by embeddings and LLMs and some post-processing. So here's the architectural overview of the flow that I'm talking about. So we have the source document. Let's say we have 3,700 CPG. So we process them at first. by using Johnson Alves multimodal LLM, because we need to convert the PDFs, diagrams, flowcharts to hierarchical JSONs and then the flattened text, because we need to get the embeddings of this text, but CPGs are diagram heavy, text heavy, table heavy. So that's why we need to have a better representation of these non-text modalities. That's why we need to generate image and table and chart descriptions, as well as flattened text from the flow so that we can index. But when we index it, we chunk it and then write into vector DB, but we use this information only to find the right page of information. Because if we just pick that set of chunk and send to LLM, it is still missing, right? That's why we also rank the splits returned by vector DB, and we just don't send the splits to LLM. We also send the parent page information, because as you remember, there's a diagram in that page. So even if we get the text version of description of that chart indexed already, the information is still missing, right? Because that description is there to find that chart by embedding similarity. But LLM, the final stage, needs to see this chart to be able to answer your question. That's why we use RAG to fish the right page, to find the right page, and then get the JSON version of this page into an LLM at the last stage so that we can answer questions. Of course, you cannot just dump hundreds of different JSON files into an LLM. That's why we also do post-processing, some query expansion, some smart routing between the different pages. That's why we have different stages that use LLMs at very high level. So let's evaluate some of the techniques that we did. The vanilla approach, as I said, would be just get the text right. So imagine left-hand side, there's a page in the CPG. So then if you just run, then you would like to represent this chart in your vector DB, because you need to find, you know that your answer will come from this page. But how are you going to index this so that your query engine can find this? The vanilla approach would be, okay, use Tesseract OCR, some OpenCV techniques, just some PDF text extraction techniques. But I just ran it on this chart, on this page, and this is why I ended up. You see, it is garbage because of the low quality of the images, maybe printed text, scanned text, image text, they all have different quality. And then usually the charts are usually not being able to utilize by Tesseract or simple PDF to text engines. So this is garbage. If I had used simple PyPDF or LangChain based PyPDF, it would fail miserably. The second one is very promising, actually, DocLink. This is one of the latest highly efficient unstructured to structured conversion engines. It can take PDF, docx, PBTX, etc., and then convert into a structured format. But it is more granular than you might expect, because it returns all the objects from the page with the coordinate information, which means that if you are happy with doing many other post-processing, because it shows the coordinates of each box, each information, its text extraction quality is good, but when it comes to do some post-processing, it is not a non-trivial process, because it just keeps the layout information with the coordinate system. But you need to post-process, convert that coordinate system into something that that your logic can understand. So it's a promising solution, but it's still not enough. There is another one, Markdown by Microsoft. This is also another open source solution. Its text extraction quality is good, but it is keeping the entire chart and tables. It only extracts the text. So it just, as you see, it just picked the part from the table caption of the chart. So it doesn't return anything from the chart itself or table itself. So this is also useless for me. So another one is Llama 3.2, 11 billion vision instruct. So this is a vision LLM, which is very promising. As you see, it's able to keep the hierarchy between the section and chart, and it's able to return the information from the chart, because you prompt the document with this LLM. You basically say that, extract all the text from the uploaded image, return it into a well-structured markdown format, and then do XYZ. So, just like any other LLM, it can hallucinate, but it is trying to. It is as good as your prompt and its own capability. It requires 11 billion. It has 11 billion parameters, which is heavy. So you would require at least 30 GB GPU memory to run it on your local. But it's, as you see, it's able to return the hierarchy really well, which is very promising. But it is still not able to return everything that I see from this table, from this page, right? It skipped the table right now. It returns something from the chart, which is really nice. Then I can use this in my RAG flow, but it is still based on prompting and the LLM and our multimodal LLM. So the idea is to get the precise page JSON for these kind of flows so that I can use this to answer the question asked by the user or send to LLM to answer the question. Because if I ask the question and send this condensed JSON information to an LLM, it's able to answer the question. Because as you see on the left-hand side, if the positive results happens, there is a sub-nested dictionary. It says that if there is a positive results, pathogenic or like a pathogenic variant identifier. You see on the right-hand side, it is the same. If the genetic testing is positive, do this, right? So if it is negative, it also explains what needs to be done, which means that if I send this left-hand side to an LLM and ask my question, what to do with a patient with TAD, if the genetic testing is negative, it's going to be able to find this sub-dictionary easily than the free text, right? That's why this multimodal LLM that we fine-tune on these kind of contexts are highly valuable, and then helped us build this flow. So let's compare all of them. We just compare 5 different approaches, right? Across 6 different criteria. Printed text extraction, Tesseract is doing good, which is there for more than maybe 20 years. Doubling is also good. Markdown is also good. All of them are also good. For the printed text extraction is a already easy to solve problem. But scan text extraction requires some pixelated data as well, understanding the pixelated data. Tesseract OCR has some solution out of the box as well. Let's say which is doing fine. Doubling is also doing fine. Markdown doing really bad. So if your prompt, if you are not looking for, if you don't know what you are looking for, Llama 11 billion VLM also bad on scan text because you need to precisely tell it where to look for so that it doesn't miss. But it increased the computational requirement when you're more granular, and then anyway. So table detection, Llama is doing well. Tesseract is not doing anything. Dunkling is doing well. So Dunkling is maybe after Llama is the most promising solution in this table, by the way. GSL Med-S, we call it Med-S because it is around 10 billion size of model, and then it's ticking all the checkboxes as you see. So it can convert diagram and flowchart to JSON, preserve document hierarchy, which is highly useful if you are making some decision based on some criteria. It can find the chart and then extract them and then create chart description and do the same for the table. That's why the most promising solution is the one that we already have in our hand, but the solution LLM is just only one part of the entire flow. This flow is a combination of multiple things, including the agentic flow, including RAG architecture, embedding selection, splitting, post-processing, etc. So it is not a trivial process. So let's get back to demo because we only have a few minutes left. So we can just go over a few more questions in a live demo and then see how it looks like, right? So if we revisit our latest question, which was what criteria make a patient with thoracic aortic disease eligible for genetic testing? So we said, of course, we do the query expansion as well. So we take this question and then change the question in a way that could be more applicable to semantic search, because we need to go ahead and then find the most similar splitters from the vector DB. That's why we do some prompt augmentation and then some query expansion as well over there. And then we send this and then find the right pages. Then LLM generate response. So right pages, if it's chart heavy, flow heavy, as I said, we already index its JSON version as well. During the pre-processing step, during indexing process, we write each page with the information that it has. If it has table, we have the table description. If it has chart, we have the chart description. And we have the chart itself, table itself, and maybe table to JSON itself, but we don't index the JSON. We index the table description or chart description, but when we find that split through RAG process, we go ahead and then check the metadata and then use the original chart and original table to send to LLM at the final stage. So as you see in this question, the question was that what are the eligibility criteria for genetic testing, right? So it needs to be able to return all this, right? This tree. And then if I just check the answer, it says it precisely summarizes. This is what LLM returns given the page, given the information that I sent from the page. So let's ask another question, maybe a more complex one. Let me check. The more complex one would be what is the suggested, let's say, treatment pathway. For type A aortic dissection with lower extremity ischemia if ischemia is persist, right? So when I ask this question, I know that this answer comes from a chart because I have checked this before. And then let's see, it again comes from this because the question is type A aortic dissection, and then if the lower extremity ischemia persist, right? So it needs to follow this and then lower extremity, and it persists. So the answer should be target vessel stenting. Let's check if the answer is correct. You see, target vessel stenting. So this is coming from multimodal. If I just use the Bayes approach, let's see what would happen for the same question. Bayes approach is just using the text version of the page. Okay, if as you see, it says involves surgical and endovascular management. So the response is given this chart response because it couldn't. Let's say it found 2 pages. It even found the pages, but since it's not able to understand the chart, it says that involves surgical and endovascular management. So another pitfall here is that since this is using LLM, if you don't provide the right flow, right chart, the right table to LLM, it may start hallucinate as if it has seen the chart, right? So to be able to check this, if this information is correct, I need to go to the original document. Luckily, I have the pages here, but I need to read all of them if this information is or not. But when I do it multimodal, I also make sure that I use all the artifacts on that page, and then it finds the right page, and then it also returns the answer, right? So let's ask one more question, maybe the last one. Let's ask this one. If in the genetic testing, if there's a positive diagnosis for pathogenic variant, what would happen? So I'm asking the same again, and then it's picking the aortic disease guideline, and according to this guideline, right? So let's check. Yes, genetic testing. According to this guideline, if it is positive, genetic testing is positive, there needs to be cascade testing for gene-based management. Let's see. And it says that gene-based management, cascade testing, thoracic aortic imaging. You see, it's picking all the information from the chart. But if I ask this with the vanilla approach by only using the TXT file that are indexed, which are most of the time people are using, so it's even able to, surprisingly, it is able to return. Maybe this information is also written somewhere around the other pages, because it found 2 pages for this. And then it is getting this information from the other pages as well. And it's not that off, right? So it is precisely returning a similar approach. Let's pick Bayes approach too. This is another approach that we are using DuckLink to compare with our multimodal. And then it's also returning. So it's more similar to my answer from chart, but the Bayes approach one is more verbose. It is using the entire text from that page probably. Okay, so I hope you like the topic. So you can reach out to us anytime you want. So Johnson Controls has been developing these kind of solutions for the last 10 years, which I'm part of for the last 6 years. So I'd be happy to help you. If you have any further question, please feel free to connect me on LinkedIn or send an email or join our Slack group. So we'd be happy to help you on your own journey as well. Thank you.